All right, this is Mr. Weyrich. I'm going to walk you through this review today. In this first section, we're doing Pythagorean theorem. We got radical answers. I got this split screen with my Desmos. So on this, find the length of the third side. I have the two legs here. So I'm going to square them. I'm going to add them. So this is 5 squared. And then I'm going to add to that. Now, this is the square root of 11. And I'm going to square it. When I square it, I take away the square root. So that's just going to be plus 11. I get 36. So then down on the next line, I'm going to take the square root of that 36. I get 6 for that third side. This is going to be 6. If I can get one that's going to not be great, that's going to be 9 plus 7 is 16. 8. Okay, so we'll do this one. We've got 8 and we've got 10. So I've got 8 squared. That's 64. And then I've got to add to that 10 squared. That's going to be 100. So the whole thing 164. And now I've got to reduce that radical. So this is going to be, I'm going to go birthday cake method, 164. If I divide that by 2, that's going to be 82. If I divide that by 2, that's going to be 41. And 41, it's not an even number. 4 plus 1 is 5. It's not divisible by 3. It doesn't end in 0 and 5. It's not divisible by 5. It's not going to be divisible by 6 because it's not divisible by 2 or 3. It's not going to be divisible by 7 because 7 times 6 would be 42. It can't be divisible by 8. It's not going to be divisible by 9, not 10. I don't think 12, 13. So yeah, this one I think is just going to be this. So I've got, well, let me finish my cake. I can divide this by 41 because it's prime. There's my candle on top of my cake. I got a pair of 2s. That's a 2 on the outside. So 2 square root of 41 is going to be my answer. So I go 2 square root of 41. And sure enough, that is my correct answer. So just be careful on that. Sometimes you get a pretty answer, sometimes you don't. Make sure you remember how to do the birthday cake method. Okay, second one here, the converse of the Pythagorean theorem. This is what we were talking about when we were doing the Pythagorean triples. Which of the following sets of numbers could not represent the 3 sides of a right triangle? So again, we're supposed to take the biggest side, we square that, and then we see if the other 2 sides added together are going to work for that. So if you remember, I had a shortcut for this, and that was, if you look at the last numbers are going to need to add up math-wise. On this one, 8 squared is going to be ending with a 4. 4 squared is going to end with a 6, and 4 plus 6 tells us that that's going to end with a 0. This is a 9, so it's going to end with a 1. So I know that this 48, 64, 79 is going to be the one that does not work. Okay, remember, you can get a question on this that says, does it work or does it not work? Hopefully you get enough practice on that to know what's coming on the test. Third section, identify the opposite adjacent hypotenuse. Just remember, here's my angle, because they tell me angle R. I go across from that angle, this side here, this LN, this would be my opposite side. Across from this right angle, this is going to be my hypotenuse every time. So this last one here is going to be my adjacent side. So I'm looking for LR or RL. In this case, LR. There we go. If I do another one, that's adjacent again. Let me see if I can get a different, yeah, opposite to L. So here's L. I go across from it. This is my opposite. That's AM or MA in this case. Okay. Just like the timed one that we had, but not as fast. Identifying trig ratios from a diagram. I made sure to give you the ones without the Pythagorean theorem. So yes, without the Pythagorean theorem. So it's going to look like this. So it's going to say, express the cosine of t as a fraction in simplest terms. Cosine is going to be my adjacent side over my hypotenuse. So I'm actually missing my opposite side here. This is adjacent over hypotenuse, 10 over 25. And if you need to check it out in Desmos, 10 over 25. And I can put this in fraction form, that's 2/5. So the cosine of t is going to be 2/5. And it does say a fraction in simplest terms. So do make sure that you check on that, okay? Sometimes I think it says fraction, sometimes I think it says decimal. but I believe most of the time, yeah, it's going to be fraction. Sometimes all of them are going to be there. So make sure that you know this is cosine of t, that's adjacent over the hypotenuse. If I go another similar problem, the sine of x, that's opposite over hypotenuse. Just make sure that you are reducing these. It's very important. Reduce that fraction or let Desmos do it for you. Same thing with level 2. I did without the Pythagorean theorem, so let's make sure that we're, without Pythagorean theorem. Express the cosine of t as a fraction in simplest terms. So this is going to be the adjacent side, which is the square root of 31 over 6. I can't reduce the square root of 31, so I believe that this is just going to be square root of 31. And then I move out of the square root, put divided by, there's 6. Square root of 31 over 6, that's my cosine. Okay, if it's one that you can reduce, make sure you reduce it, but there's going to be just some radicals and stuff in here on the one on the test. It's going to be level 2. Okay, using trig to find a side. This is what we were doing yesterday and the day before. So when we look at this, we have to say to ourselves, okay, what do I have? In this case, I have this side that's my hypotenuse, and I have this angle here. And then what am I looking for? Well, this would be the opposite side. And there's nothing there. This is my hypotenuse, so this must be my adjacent. I have my hypotenuse. I'm looking for my adjacent. Adjacent and hypotenuse is going to be cosine, so I'm going to use cosine. So when I set this up, cosine is always adjacent over hypotenuse. So it's the cosine of 65 is going to be equal to my adjacent side of x over my hypotenuse of 9.4. It doesn't actually matter which one is missing, my hypotenuse or my adjacent side. If it's adjacent and hypotenuse, I know that I'm using cosine. If it's opposite and hypotenuse, I know that I'm using sine. If it's opposite and adjacent, I know that I'm using tangent. All of this stuff is just going to stay exactly like it is. But then where the x is, top or bottom, determines what I'm going to do. This one has the x on the bottom. So when I rewrite this, I am multiplying, that's 9.4 times the cosine of 65. Okay, that cosine of 65 stays together. That's the angle. Now I probably need to make sure in my settings that I am on degrees. It's on degrees. Always make sure of that before you start typing in answers, especially on the test. This says 3.97. So rounded to the nearest tenth, that 9 is actually going to round up when I round it. So this is going to be 4. Okay, if I check a new problem, did I eliminate? No, I didn't eliminate any of the types. Okay, so again, on this one, here's my angle that they gave me. This is my opposite side. This is my hypotenuse. That's sine. Okay. On this one, here's my angle. This would be my opposite side. This is my hypotenuse. This is my adjacent. I have the adjacent. I'm looking for the hypotenuse. Adjacent and hypotenuse is still going to be cosine. So this is going to be the cosine of 40 is equal to, but this time I have my adjacent side, that's 64, and I put that over x, that's my hypotenuse. So see, the cosine setup does not change with the x being on the top or the bottom. The setup of any of them, sine, cosine, tangent, is not going to change with the x being on the top or the bottom. What changes what you have to do. This one had the x on the top. I multiply that 9.4 by the top. This one has the x on the bottom. This one's going to be division when I rewrite it. So that's 64 divided by the cosine of, this is 40. Okay, cosine of 40. So I've got 83.54. That's going to be 83.5. Okay. My next section, the trig word problems. Let's go to the problem. Make sure that this isn't, most of them are going to be angle of elevation or ladder leaning across or something like that. So the best thing that you can do on this is draw it. Aubrey's flying a kite. She's holding her hands a distance of 2.5 feet above the ground and letting all the kite string play out. So here's a little stick figure lady, and she is 2.5 meters off the ground holding up this kite string. And we've got this right triangle, right? Here's my kite. Yay, Charlie Brown kite with the little tail and the bows and whatever, okay? It tells me that the angle of elevation from her hand to the kite is 25 degrees. This is going to be 25 degrees. And the kite string is 150 feet, 150 feet. How many feet is the kite above the ground? Ooh, this is going to be fun. Okay, so this is my angle. This side over here is my opposite. That's how many feet it is off the ground. And then I have my hypotenuse. If it's opposite and hypotenuse, I'm going to use sine. So my setup here is going to be with sine. The sine of that 25-degree angle is equal to my opposite side of x, that's the height off the ground, over my hypotenuse of 150. So I'm going to put that as 150 times the sine of 25. So I get this 63.392 whatever, blah, blah, blah. But they gave me that extra information, right? They're asking me, how high is the kite off the ground? Well, this is how tall that kite is from where she's holding the string, but she's 2.5 meters off the ground. So I'm actually going to take this and I'm going to add to this 2.5. There's my answer. 65.89 is how many feet that is off the ground. Okay. So that's where we are on the word problems. It's always going to be make a drawing, make your triangle, put any information that they give in there with it, and you should be great. And then the last one here, the special right triangles. Let's take a look at this problem. Here we go. The side opposite the 30 is square root of 10, and they want me to find the side opposite 60. So this is x, so I would take x times the square root of 3. So when you multiply square roots, everything that's under the square root stays together, everything that's outside the square root stays together, and that's where you do your multiplication. This is going to be 10 times 3 is 30, so it's the square root of 30. And I know that that one's not going to factor out, so just square root of 30 is going to be good. Okay, we come right back to where we started with reducing that radical. This is my side opposite 30. This is my hypotenuse. This is my side opposite 60. So this is the most steps I need to take. This is 2x. So when I move it down here, this is going to be 3 over 2 or 1.5, something like that. And then I'm moving it to here by multiplying by the square root of 3. So I write just this complicated kind of looking fraction. 3 square root of 3 all over 2. Okay. And there's my correct answer. Okay. Simplest radical form, rational denominator. If you get stuck on this, make sure to ask for some help today. Show up to tutorials. Hopefully this helps you out, and good luck on the test.